So let's look at how do you write equations for polynomials. We've done a little bit of this already. What I mean with that is this: if I told you that a polynomial has the solutions 2, 3, and a negative 4, then I think most of you can do this. For 2, you would write x minus 2 as a factor. For 3, you would write x minus 3. And for the negative 4, you would make it an x plus 4. And then this would be a polynomial that works. Okay. I do want you to keep in mind that it's probably not the only polynomial that works. What I mean with that is the following. Let me copy it and I'll leave a little space. So what if we stuck a number in front here, like a 2? Would that change the solutions at all? Well, I don't think it would, because if I asked you to solve it now, you would say, well, that equals 0, so that happens when 2 equals 0, which is never, or when x minus 2 is 0, which is when x is 2, and you can sort of see that it would work the same thing for here, that you would get the 3 back here and the negative 4 there. So putting a 2 there doesn't do anything to the actual solutions. Now I change the shape of the graph, especially if I make it a negative 2, or if I make it a negative 2 over 3. So we're changing the shape of the graph, but not where they cross the x-intercept. How does that work with fractions? Well, fractions work pretty much the same way. If it's a positive half, that is a solution, then you would write x minus a half. And for a negative 2/3, you would write x plus 2/3. And for 0, you could just write x minus 0. Now it's custom to not leave it that way. X minus 0 is just x, and we usually write that one first. And we don't want to have fractions in here, so to get rid of a half, you could multiply by 2. So 2 times x is 2x, and this one just becomes a negative 1. Okay, so that's sort of just like a slip and slide method. So the 3 just slips out in front. I think I said that backwards. The 3 just slides onto the front, and the 2 slips on down. So that would be one way to write this, okay? I said one way again because you could put a 3 in front of here, or a negative, or there are lots of numbers you can stick there. So that's sort of the essence of that. Well, that doesn't quite work like that when you have square roots imaginary parts. First, let's just look at a quadratic and see what happens when we solve it. So if I were to solve this, okay, and I want to know what happens with quadratics to end up with a square root, well, in this case, let's use this quadratic formula. So that's b squared, which is 9, minus 4, a is 1, and c is 6, divided by 2 times 1 is 2. So the solutions to this quadratic are going to be a negative 3 plus or minus 4 times 6 is 24. So this is going to be a negative square root of 15. So you can already see a little bit what's going to happen here is that square roots always come in pairs, and so do imaginary parts. It's always going to be plus or minus the square root of something, or in this case, even the imaginary part, but it also comes with a plus or minus. So the plus or minus means that they come in pairs. So these answers come in pairs. And we actually have a fancy name for that. That's called a conjugate pair. Well, a conjugate pair is something we've worked with before. We're more familiar with it with like a minus b and a plus b. And a minus b times a plus b is a squared minus b squared. If you're not really sure, what I mean with that is this. What if it was x minus 2? And then that's a little mistake. That should be an x plus 2 then. So what if I have an x minus 2 times an x plus 2? Okay, what do you get out of that? Well, I think most of you are comfortable to write that as x squared minus 4. Well, that's the conjugate pair. That works for solutions as well. What I mean with that is this. If 5 plus 2i is 0, then 5 minus 2i is a 0. Okay, that would be sort of written in a fancy way here. So if a plus bi is a 0, then the conjugate pair a minus bi is also a 0. If x is 2 minus the square root of 3 was a 0, then 2 plus the square root of 3 had to be another 0. Okay, and that's written over here. So keep in mind, square roots and imaginary answers, they come in pairs. We can use that to write the equations. So if I give you that one of the solutions is x plus 2i, we just talked about, then that the other solution then must be 5 minus 2i. So when you write that, it helps if you think of this as their own little factors. So this will be x minus, and then the factor 5 plus 2i. And then this is x minus, and then 5 minus 2i. So the reason I'm using a little factor here is because I don't want you to make this the plus. The conjugate pair comes from this part here, 5 plus and 5 minus 2i. Okay, let's clean it up a little bit. So this is going to be x minus 5 minus 2i, so it's distributing the negative. And this is x minus 5, and then this negative makes that actually a positive 2i. And you do end up with conjugate pairs here. Now they might be a little bit harder to see, so I'm going to put this over here, put this one over here, and this one over here, and I'm going to back the red for a second. Let me see if I can do it this way. So let's see what I just did. So inside this first one, I wrote x minus 5 minus 2i. So x minus 5, that's going to be the first term. That's a. So this is an a, and then 2i is a b. So this is a minus b. What do you have here then? Well, that's x minus 5 again. Well, that's a, and now it says plus 2i. And 2i is b. So you see you have an a minus b, a plus b. Well, then this is a squared minus b squared. So we can use that to multiply this out pretty quickly. So you can just write this then this way. This is x minus 5 squared minus 2i is b, so 2i squared. X minus 5 is x squared minus 5x twice, that's minus 10x, and a negative 5 times a negative 5 is a positive 25. And then here you get minus 2 squared is 4, and I squared is I squared. Well, I squared is also written as a negative 1. So what ends up happening is that you do not end up with any imaginary parts. 25 minus a negative, sorry, this ends up being 25 plus 4, because a negative 4 and a negative 1 makes a positive. So that will be plus 29. So you end up with a quadratic without any imaginary parts. Okay. The reason I'm pointing this out, this a minus b squared, or this a squared minus b squared part, is because if you didn't want to do that, you'd have to do 1, 2, 3 multiplications, and then go on to the next one, and then 3 more, and then 3 more. So that's 9 multiplications and a whole bunch of adding and subtracting. So it just helps to recognize the conjugate pair there. It also works with square root answers. So we just talked about that these two always come in pair. So it's basically the same thing. So it's going to be x minus, and then 2 minus the square root of 3, and then x minus, and then 2 plus the square root of 3. So this will be x minus 2 plus the square root of 3, and this is x minus 2 minus the square root of 3. And then here the conjugate pairs will be x minus 2, that's a, so that's a squared, minus the square root of 3 squared. And again, you see that you get rid of all your square roots. So this is 4x plus 4, and then the square root of 3 squared is just going to be 3. So this quadratic, x squared minus 4x and 4 minus 3 is 1, has these two solutions. Okay? So I purposely picked two positive numbers now. So if this had been a negative 2 minus the square root of 3, what would have changed in this problem? Well, let's write the changes down, and we'll do this in blue a little bit, and we'll see what happens a little bit. Make sure I did that right. Okay, so we would also have a negative 2 plus the square root of 3. So this would be a negative 2, this would be a negative 2, so you get x minus a negative, so that becomes x plus 2, and this negative and that negative becomes a plus, so this would be x minus 2, this becomes an x plus 2, and x plus 2 squared will be x squared, 2x twice, so that's 4x, still plus 4 minus 3. So not a whole lot changes there. And this is another reason that I still use little brackets around here. I don't want to forget about this negative here, and this double negative making it a positive. So I think it just helps to eliminate some common mistakes by doing that. Okay? Alright. So how does this work in context of polynomials? Well, let's look at an equation for a third degree polynomial that has the following zeros. Why is that third degree part important? Well, it's important because of this. you know that this is one answer. The other solution that comes with 2 plus is 2 minus the square root of 3. And now let's check how many answers do we have. We have 1, 2, 3. So third degree, only 3 solutions. We know that these are all the answers that we could possibly have. So the factors must be x minus 2, and then x minus 2 plus the square root of 3, and then x minus 2, minus the square root of 3. And then we just did this one, so hopefully I remember it. So that should be x squared. And then I believe this one is minus 4x plus 1. Okay, so that is a third degree polynomial. And you can just leave them sort of in fractive form. As long as we don't have any square roots in the, or fractions, or imaginary parts, then this is okay. So this is a reasonable way to write that. So let's make it look like a function. Okay, let's do this one more time. And now we'll also look at what if it has to go through a specific point. Okay, and this is the part, this point here is going to make this number here sort of fixed, and we'll need to figure that out at the end. So let's start with the beginning. So let's see how many zeros are given. 1, 2, 3, but this one also comes with its little sister or brother, so that's 4i, and it's fourth degree, so that's it, 4 zeros. So it's x plus 3. The 0 is just going to be an x here, and then that's x minus 4i, and then we get x plus 4i. Well, I can't leave those, so you got to multiply these out, and this is an easier form of it. So this is just going to be x squared minus 4i squared, which would be x squared minus 16i squared. And I squared is worth how much again? I squared is worth a negative 1, so this becomes actually x squared plus 16. So right now, this is my first sort of guess at what the polynomial is going to look like. Okay, now we can go look at this point. So given this point, so if this has to be on there, then when I plug this x into the equation, so when I plug in a negative 1, what should you get out of it? Well, you should get this y out of it. So, well, that means that you can sort of figure out what you need. So we're going to put a little a here. That's just a placeholder for the constant that we need to make this work. Okay, now keep in mind a is often 1, but it could be anything else too. So we just get this, a, and then x is worth a negative 1, and x is still worth a negative 1, and x is still worth a negative 1. We need to add 16 to that one. And all of that is supposed to come out as a negative 68, because this is supposed to be where the y value is, right? And then you multiply stuff. So negative 1, well, we'll just simplify first. So negative 1, and that's going to be negative 1 plus 3 is 2. And then negative 1 squared is 1, and 1 plus 16 is 17. So 2 times 17 is 34, with a negative, and then an a. Well, to make this work, a would have to be, divide negative 68 by negative 34, a has to be 2. So apparently, the equation that I'm after is going to include a 2. So the polynomial will be a is 2 times x plus 3 times x squared plus 16. And hopefully this is going to work for the point that I gave you. Thank you.